Well, hello everybody. I'm Alejandra and I'm an industrial PhD under the supervision of Manuel Soler as well. And I'm here, I work for a company called Flight Keys, and we are together looking with the university to see how we could implement control avoidance in a commercial flight planning system and what would be the operational implications of such an adventure, so to say. So before we begin, the sponsors of today's presentation are Flight Keys. Flight Keys, a flight planning software company based in Vienna and operating with airlines all around the world. We have, or Flight Keys has, three core products. Flight Keys 5D, which is the flight dispatching tool that we're using for this research paper, Space Keys for GPS prediction, and Loretta, which is a tool for pilots to use in flight, but we don't care about those two. So before we begin, even though Irene has already made a very good presentation, let's introduce the problem. So contrails are those thin white lines that we see in the sky when we fly. They appear when the hot exhaust gases enter into contact with the cool ambient air, and then the soot particles act as condensation nuclei for the water vapor around it. They condense and they freeze because it's very cold, forming a cloud behind the aircraft. Contrails are nothing special. They're nothing that it's inherently different from a normal cloud, like Dennis said. They're not spraying us, but they do have the ability to alter the energy balance of the atmosphere by reflecting part of the insolar radiation back to space, creating a cooling effect, but also reflecting, trapping underneath the layer of clouds, part of the radiation, under the layer, creating a warming effect. Overall, the cooling and warming effects during the day are kind of compensated, but overall, it's said that, especially in the northern hemisphere, it's more warming than it is cooling. When we arrive in nighttime, then this is definitely warming because there's no reflecting back to space. And yeah, so overall, we say that contrails are warming. How certain are we about this? There's a lot of uncertainty from the scientific community surrounding what is the real value, but overall, it's believed that contrails have a warming impact in the energy balance. Contrails can form as cooling, and then as the day evolves, transforming to warming, as we can see in this video. As the contrail lasts longer through hours, its own energy balance can be changed. And overall, we say that non-CO2 effects, but especially contrails, could be responsible for 2/3 of aviation total's climate impact. Okay, so having said this is the problematic. Now let's go into the state of the art, what has been going on. So I divided this in three core sections. The first one from an academic perspective, we have different studies that are looking at improving the prediction models for contrails, such as the ACCF model, the COSIP model, the Google model, etc. Then we have the incorporation of new technologies like ground cameras or satellite images in the detection of contrails and being able to match these contrails to the aircrafts that actually generated them. This is, for example, what Irene was presenting before. Then we have investigations that look at reducing the uncertainty on how warming a contrail can actually be. And then last but not least, kind of also what Raul is doing, we are looking at other sustainable aviation fuels and see what the impact of altering fuels can have on contrail properties. Then we have from the industrial perspective. From the industrial perspective, we have the development of tools that are able to use part of this model to predict where contrails are going to form and hopefully reroute around them. This is what, for example, Flight Keys is doing. Then we have the improvement of humidity sensors in aircrafts to be able to predict with better certainty where contrails is going to form. And last but not least, we have the experimentation of contrail avoidance using real flights. And then last but not least, we have regulation. So I don't know if, I guess some of you might know, but especially in the EU, we are running tight. Sustainability regulation is catching up with us. The MRV, the Monitoring, Reporting, and Verification for non-CO2 emissions, has been in action from 2025, from January 2025. Airlines in the EU are expected to report their non-CO2 emissions, and how this will eventually be part of EU ETS or CORSIA, which is a European and worldwide sustainability relations, is still to be seen, but this is a very present concern that airlines have to start thinking about for the coming years. So what are my research objectives? We have implementation of control avoidance into a commercial flight planning system. We have flight trials, so can we actually convince airlines to fly control avoidance flight plans? And last but not least, knowing that regulation is coming up on us, can we actually use the things that we are experimenting with to somehow go one step ahead and maybe even provide some feedback to policymakers about how could this be done in a way that would suit operators more? So the first point is the question, how can flight planners implement control avoidance into their system? And that is what has been done in Flight Keys. So the first thing, we import control forecast models as a separate weather layer. And all flight optimizers, like the same way that flight optimization tools are here in the university, they are cost minimization tools. So if we set up a cost to CO2 or we set up a cost to control avoidance, then the optimizer will try to reroute around control areas. The higher the price, the more we will try to reroute. The lower the price, the less we will care about it. Then once this is done, we have to configure this in airline systems so that then airlines can plan their flights to avoid control avoidance with different cost sets. We see that we did that with TUI Fly and American Airlines, which are two of Flight Keys customers. And then last but not least, if the flight manages to take off with a control avoidance flight plan, is there a way for us to verify that this flight was indeed successful compared to the cost optimal flight that was originally planned? And this is done, Flight Keys doesn't do it themselves, but we do partner with DLR, controls.org, or Google, for example, but also Irene's work is in part to use satellite image to exactly verify this point. So for example, we did a simulation 2024-2025 with some of American Airlines flights. So we simulated 11,172 flights, from which 1,590 were predicted to form warming contrails. This is all in a testing framework. So these flights were not actually flown. This is, if we have to tell American Airlines, okay, how much would it cost you to have flown these flights during this week of operations? What will they tell them? So we can see there, we filtered out the flights for the US and North Atlantic, and we can see here a screenshot of one of the days of operations, how the contrail map was looking. The redder, the more warming, the yellower, the least warming. And here are the first table of results. So what we can see, we see the different costs thresholds that we set. We set a cost of $5, $20, $50 for this cost areas. And we can see the different operational KPIs. So we have the cost, time and fuel, and then the environmental KPIs. So what is interesting to see is that for different costs, even the higher the cost, we can have a reduction in total energy forcing of the contrails of around 50% with an increasing cost of 0.1%. The column to the right, this is hard restrictions approach. This is linked to a paper that was published last year, which essentially looked at this exact problem, but instead of a cost-based avoidance, we're doing it with no-fly zones and hard restrictions. So then we can look specifically at the breakdown of the cost, and we can see, to no one's surprise, that the biggest source of cost increase comes from fuel, followed by time, and then engine cycle cost. This is through the increasing and decreasing, the yo-yo flights that they called. Whenever you increase and go down and increase and go down the flight level, that puts the engine in higher thrust settings, and that leads to increase in engine cycle cost. So we can see there's not en route changes, so en route changes to the price, but this is mainly due to the fact that 90% of the flights, or even more, happened within the US. So we don't have a change in price by lateral rerouting within the US, but this would be an interesting experiment to see in something like Europe, where there is different overflight charges based on where you're flying. And these results are actually in line with other papers, for example, one published by Abul Faisal from university, which also finds out that you can have a reduction of around 50% in energy forcing with an increase in operational cost of around 2% or less. Then we look at the flight trials. So we actually managed to do some flight trials with some of the customers, including TUI Fly. The latest one was in February of this year, and from 313 flights of an entire week, we managed to reroute 96 flights from the 204 flights that were predicted to form warming contrails. It was also a very tough week, I have to say. Usually you're looking at 10% of flights have contrail, are estimated to have contrail warming, and in this specific week, it was just preposterous because there were 200 flights out of 300. But still, they did really well. They managed to execute 96. And the results are more or less in line with what we presented before. So we have a reduction, an increase in cost higher. Oh, sorry. Okay. Okay. Higher than was expected, with a decrease in energy forcing of around 40%. But what was more interesting is that we managed to get feedback from both the dispatchers and the pilots on what was the main source why they couldn't follow or they couldn't file a control flight plan. And to nobody's surprise, within the aerospace, within the airline industry, is kind of an inside joke, the biggest problem was ATC. And this brings back to the point that we can't do this, researchers and airlines alone. We need ANSPs to be part of the equation. And it's very hard to make ANSPs and ATC change the way they operate. And then to end up roadmaps and achievements, we have the implementation of control models into a commercial flight planning system, check. We have the flight simulations, a publication of first results. We published a conference paper in 2023, the hard restrictions paper in 2024, and hopefully we're gonna have another paper with the soft restrictions approach this summer. And then we have some flight trials with TuiFly and American Airlines. And then we're looking already into the MRV, CORSIA, the UETS, and how can we then use everything, all of the experience that we're gathering to see how could this be implemented in the years to come from a regulatory perspective. We also attended many conferences. These are from 2023 onwards, so it's not just this year, but we did attend many, mostly commercial airline events. We tried to get airlines engaged into this type of research and being able to, and hopefully get interested in doing trials. And yeah, I'm looking forward to go to more events in the years to come. The end.